record voice. I should have looked. Okay, so now I can identify the common factors. From left to right, slowly identify each common factor.
Sorry, where did the 12 from? The negative 12?
3 times 4 multiplied by negative 1. Very good. So then, what do? I want from left to right the first common factor.
4x minus 1.
Okay, one more time. From left to right, the first common factor.
X minus 3.
6 minus 12.
The first common factor is 6. We have not gotten here yet. The first common factor is 6, indeed. Now, the next common factor is that I see in both terms. Very good. Now I have to ask myself which power, and the power has to be the smallest of the two. Very good. Next common factor in line that is present in both terms. Very good. Now I have to ask myself which power. Something that has no power is 1. No, it's not clear what I just said. Something that has power 0, that is 1. So the smallest power for something to exist is 1. If the power it does not exist or is 0, then the answer is 1, assuming that this quantity is not 0. Okay, so between power 2 and power 1, you don't have to write it, but let's write it just to make sure that it's clear. It must be power 1. Now I have brackets. You can use parentheses, but I'd rather put brackets because I may have to use parentheses inside. Good. So from this term, I took out 6, I took out x minus 3 cubed, and I took out 4x minus 1. What is left inside?
You still have 1 4.
Negative 2.
4x minus 1. One more time. 6 is out. All of these are out. From power 2, I put out 1. So how many I still have inside?
1.
Yes. If you distribute this to this, then you get that. 6 x minus 3 cubed. This times this is 4x minus 1 squared. So now I'm here with minus. What is left? 2 indeed. What about this?
X minus 3.
Very good in parentheses. What about this? It's completely out. Very good. Any questions?
Yeah. Where did 2 come from?
6 times 2 is 12. That's okay? Now I am allowed to do this. Why? Because I'm simplifying factors. 4x minus 1 at the top, and now is a factor, not part of a term. Good. So then, 6 x minus 3 cubed, what do I have in parentheses? 4x minus 1.
2x.
Very good.
6.
Very good. Awesome. So then finally I get 6 x minus 3 cubed. And what else in parentheses?
Square plus 5.
Very good. This is it. 2x plus 5 indeed. Any questions for me?
Where'd you get the 2x plus 6?
Negative
Should
2
be
times
a-
x and negative 2
Oh,
to,
you still go ahead.
yes,
Okay,
yes,
all right. Okay.
yes, Kelsey?
Would you number 4 on the white pink paper?
Yes. Any questions on this? Yes, please, Heather.
The bottom is still gonna be cubed or is it gonna be squared?
4 minus 1 is 3.
Okay.
I took 1 away from the top and I took 1 away from the bottom.
What about the one in the parentheses?
But can I simplify this with this? No.
Okay.
It's the same for the same reason I cannot simplify this with this.
So this,
Yes.
so the 4x minus 1 is for 1.
You mean this one?
Yes. Why is it not negative?
Why is it not negative?
Yes, that is 1.
You have 3 apples. You have 3 apples and I take 1. Do you still have, you have 4 apples and I take 1. Do you have negative 3 apples or you have positive 3 apples?
Well, you know, in the exponential, if it's division, that you subtract the.
Right, but then you bring it to the top. 1 minus 4 is negative 3 at the top, but you have to bring it to the bottom now and it's positive. I understand what you mean. So, for example, if I have x divided by x to the 4th, I copy the base and subtract the exponents. So now you do have x to negative 3, but this is 1 over x to the 3rd. Still comes back to the denominator. So it's better to say in this case, I'm removing 1 from the top, I'm removing 1 from the bottom. I don't have to bring it up and then bring it back down. But it's acceptable. The procedure is correct. But then you have to bring it back because you cannot leave negative exponents in the final answer. So it's better to say, I'm removing 1 from the top, I'm removing 1 from the bottom. How many are left at the bottom? I had 4, I'm removing 1, there may be 3. There must be 3 left. Is that okay? Very good. I forgot what I was doing. So what am I doing?
4 in the white paint.
4. On this? 4. Yes. Does the equation define y as a function of x? This was also in my math lab. So I was hoping that you got to this. 3 plus 4x equals y squared. Good. So I'm asked to identify whether this is a function or not. How do I proceed? What do I have to show? Yes. So the idea is that I have I have to solve for y. That is the key. Very good. So let's solve the equation for y. What what do we have to do? Good. If I want to solve for y, I have to apply square root to both sides. So then y equals?
The square root of 3 plus x, 4x.
Something crucial is missing.
Plus or minus.
Ah. So now we have to make a conclusion, draw a conclusion. So let's say I pick a number, x equals 0. What do I get?
3. Plus 5.
I just picked a number. X equals 0 and I got y equals 3, the square root of 3, and y equals a negative the square root of 3. What do we conclude about this equation? Does it represent a function or not? Not. Because for one x value, exactly, not a function. Because of the plus or minus. It's 2 functions, actually. Very good. Next problem. Next question, please.
What about number 5 on the white?
Yes. On the same page?
Yeah.
F of x equals 5x cubed minus 6x to the 5th. Okay, so the question here is this function symmetric? What does that mean? What do I have to do? So what am I really asked? Here's what I'm asked.
Function of negative x.
Without graphing, because I'm asked to do this algebraically, without graphing this, is this function symmetric with respect to the y-axis, which means what type?
Even.
Even. Or is it symmetric with respect to the origin, either this way over the origin or over this way? What type of function will that be? Odd. Good. So that's the question. Without graphing, I have to make a decision. Now, let me refresh your memory on the two possibilities for even and for odd. What is the algebraic relationship? We identified the geometric, right? Symmetric with respect to the y-axis or with respect to the origin. But what is the algebraic relationship for an even function?
Even number.
That was cute.
F of x equals f of negative.
F of negative x must equal f of x. What is the relationship for odd? And I have to start with the same thing.
Negative.
Exactly, exactly. So since both relationships have this key, this is my starting point. That's where I start determining f of negative x. That's my first step. So this is the function. We want to find this. Please dictate. What do I have to write?
5
Yes, indeed.
into minus x.
To the, very good, minus
6 into minus x.
negative x to the fifth. That's it. So I have to determine this piece. I need to find it in both cases. So that's my starting point. Good. Now I have to think. When I raise negative x to the third power, negative x, negative x, negative x, what do I get?
Negative.
X to the third. Very good. So then I get negative 5x to the third. Now I raise negative x to the fifth power. Negative x, negative 5 times. Negative x to the fifth times negative 6 in front. Yes. So now, finally, after I determine this piece, I ask myself 3 questions. The first question is, does this equal f of x? If I say yes, then it's even. Does this equal what?
Negative f.
Very good. If the answer is yes, then I conclude the function is symmetric with respect to the origin or odd. And the third option is none of the above. Only one of these 3 answers must be yes. Not 2, not 3, just 1. Okay, so here's my first analysis. For f of x, is this identical with f of x? Yes or no? No, of course not. So this is out of question. Now, I need to compare this to the opposite of f of x. No problem. How do I find the opposite of this? Right? So now I'm asking myself, is this identical with this? So therefore, the function is odd. So in both situations, I have to calculate f of negative x. If I show that f of negative x is not identical with the function, then I say it's not even. But it doesn't mean that it's not odd. So for odd, I have to compare f of negative x to the opposite of f of x. If they are the same, I'll say the function is odd. Now the question is, so what? Okay, the function is odd. So what did I accomplish? Well, you will see in chapter 3. It's so much easier to graph a symmetric function than a non-symmetric function. Is it such a big deal? Not really. But it's important. Okay, good. Next question, please. Anything else from here? Or I'll go back to the book for other problems. Which one? 9. We did 9 in class. Yeah, we did 9 in class. All the rate of change, average rate of change, everything was done in class last time. In 9. I simply copied it from there. And we cannot do 10. Anything else from this form? Which one? The piecewise defined function? At the end. At the end. I just want to finish all the topics.
Can you explain,
Yes?
for number 6, could you do the local maximum or local minimum?
Yes. On the graph?
Yeah.
Yeah, I copied this. It's posted at solutions. I copied it on one of the class work. So this is the local minimum because I can show the open interval. So it's at 0, 0. This is a local maximum because I can show the open interval. And this is a local maximum because I can show the open interval. The function must exist on both sides. So I will say that this is when x equals -2, local max is 1.75.
I put 1.5.
That's fine.
Yes.
It's closer to 2 than 1.5, but that's fine. Okay, the same thing here. But x equals 2, local max is 1.75. And this one, when x equals 0, local min is 0. Is that okay?
No, I don't understand.
So it's
It's 0, 0.
Wait, I'm sorry, can you explain I got 1.75 one more time?
It's between 1.5 and 2, and it's closer to 2.
Okay, I got
The height. So this is 1, this is 1.5, and this is 2. And this height is closer to 2. So I estimated it 1.75.
Okay.
Yes.
So 19 miles to 1 because I put 1.98.
That's fine. Yes, that's fine. Yes, it's closer to 2, so I accept that. It's a little bit less than 1.98, but I understand it's difficult to read. Anything else from this form?
So the maximum value I put -2 1.5 and the local minimum value x. The local minimum was 0, 0.
Yes. So remember, local minimum, I have to show the open interval where all the other values are bigger.
Right. Right. Gotcha.
Anything else from this form?
Okay. Can you answer question H? The intervals in which the function is.
Yes. So the function is increasing between -5 and -2. -5 and -2. Union 0 to 2. So f increasing between -5, -2, union 0, 2.
So you don't put the interval notation of -5.
No, we don't put a bracket. No, the intervals have to be open.
Okay, so it's just 5 and that's 2.
Not the y values, the x values. Between -5 and -2, the function is increasing. Between 0 and +2, the function is increasing.
Okay, that's 5.
Oh.
I'm sorry?
The I.
Oh, it's the same thing. It's between 2 and 0 and -2 and 0 and 2 and 5. Yes. Yes.
Can you do K and L also on the map here?
Yes. Okay. Find x values for which f of x is -3. F of x equals -3. What is given when we are told f of x equals -3?
Plus X.
What are we given? If I say to you f of x equals -3, what am I giving you?
X.
Nope. If I'm not giving you x, what am I giving you then? y. F of x equals -3 is this line. Y equals -3, and I read -4 and +4. Okay? And the other one was what?
So the answer would be y equals -4 and y equals +4.
Yes.
And the next one just L.
Find the values of x for which f of x is positive. As you see, f of x is positive, meaning the function is above the x-axis between -3 and 3, but not at 0. So I have to write between negative, why am I writing this? Between -3, 0, union 0, 3. If I had the equal symbol here, I would have included 0, and I would have said between -3 and 3. But I don't have the equal symbol. So I have to leave it open at -3, open at 0, and open at 3. Anything else from this?
Number 11.
Say it again.
Number 11.
Okay, so let's look at transformations. Okay, so for transformations, we are given f of x equals -2 the absolute value of x minus 2 plus 4. Good. So so the question here is, use transformations to graph this function, find the domain, find the range, and find the x and y intercepts algebraically. So let's start with that. So I want to find the x-intercept, or intercepts, I don't know. How do I find the x-intercepts? For any function, not just for this one. I know it's late, but we cannot forget how to find the x-intercepts for any function. That's it. I said y equal to 0. Y is the function itself, -2, x minus 2 plus 4 equals 0. What will be the first step? And please say we must clean it up. Good. So how do I clean this up? What I should say is simplify it, right? So say it again, Cassie. Yes. Then
Distribute an absolute value.
never distribute in absolute value. Absolute value is not a grouping symbol. Never treat absolute value as a grouping symbol.
Divide by -2.
Correct. Very good. So the absolute value is not a grouping symbol. I know it's tempting, please. So I have x minus 2 in absolute value equals 2. Now I think, I cover this and I think, which numbers in absolute value will give me 2? So the answer is,
2 -2.
that's it. So the inside numbers, x minus 2, must be 2 or -2. Now I solve the first equation for x. X equals 4. Excellent. Second equation, solve for x.
-4.
Careful.
Wait. 0.
Perfect. So what are the x-intercepts for this function? Awesome.
0, 4. 0, 0.
Excellent. Should I look for the y-intercept or this is it? That's it. Good. Very good. So now I look at this function and I think, okay, what base function was used here? If you simply read it, you don't have to read it out loud, but if you simply read it, then you'll say, oh, I know. The base function is?
Absolute value of x.
Perfect. Thank you. Number 2, remember the order of operations. So let's go back to this function for a moment. If you ask me to evaluate this function for 5, x equals 5, I will perform 5 minus 2 first. Then I will apply the absolute value, multiply by 2, then multiply by negative 1, and the last, very last step is plus 4. This is the correct order of operations for the transformations as well. So please tell me, what is the first transformation on the absolute value of x?
Please, madam, just repeat that.
When I evaluate this function, I will perform this, then multiply by 2, then by negative 1, and then up 4. I mean,
First transformation is minus 2.
exactly. Yes. So x minus 2. What does this do to x, the absolute value of x?
Moves it right 2.
Very good. A right shift of 2. Transformation 3 is on number 2. And I have to break that negative 2 into 2 parts because there are 2 transformations in there. Normally, when I finish this, I will multiply by negative 2, right? But in this case, I have to break it up into 2 parts. So first, I will say twice x minus 2. What type of transformation is this? If it doesn't touch x, it must be a transformation on
Oh, yeah.
y. So what type of transformation is this? Say it again.
Up 2. Up 2.
The plus. The plus is up and down. I don't have plus. This is multiplication.
And part and stretch.
Vertical stretching by a factor of 2. Number 4 is a transformation on number 3.
Did we lose the negative 2?
Not yet.
Okay.
I have to break it up into 2 because it's 2 transformations. Multiplication by 2 is 1. Multiplication by negative 1 is something else. Yes. So that's my next step. What does this do to this? Reflection. Very good. Reflection with respect to what? Very good, the x-axis. And the last transformation, which is a transformation on number 4, what does it do?
So plus 4.
Yes. Exactly. Up 4. Very good. Excellent. So now I go back to my chart, to my coordinate systems. I don't have to use them if you know, all of them. So I start with the absolute value of x. Please review that list of basic functions. Then we shifted, as you mentioned, to the right 2. So this is the absolute value of x, and this is the absolute value of x minus 2. Then you told me to vertically stretch by a factor of 2. Okay, so I'm going to vertically stretch by a factor of 2. If this is 1, so it's going to be something like this. So this is the absolute value of x minus 2 with 2 in front.
You wouldn't go to the next graph and do that?
Say it again.
You wouldn't do that on the next graph?
If you want, you can. Yep, I just wanted to have both because it's easier to identify. Then you told me to reflect. Okay, I reflected. And then you told me to do what? Final step. Exactly, you told me to go up 4. 1, 2, 3, 4. I'm going to graph the last function one more time. So negative 2 x minus 2 plus 4. Now, from this graph, the blue graph, can you identify the range for us? Exactly. Very good. So the range, negative infinity to 4. Perfect. Now, because I have the x and y intercepts determined algebraically, I'm going to present a very nice graph. So it crosses at 0, 0, it crosses at 4, 0, and it's right up here at 2, comma 4. And this is indeed f of x, negative 2, the absolute value of x minus 2 plus 4.
How did you determine the range?
From the lowest y value to the largest y value. Because we were here with the green graph and we had to shift it up 4. Very good. Anything else before I look at the book and for other problems? Anything else? I'd like to look at a, yes, please.
Problem number 1 on the right.
Any particular one, or we did see whether complete the square.
I put the number 3b.
Right, so this is typical for taking square roots, but first I have to divide by 3 to simplify it. So x plus 4 squared equals 9, and then we take the square root. So x plus,
Back in back squares on that one.
you simplify by 3 first to clean it up, and then you take the square root from both sides. And what do we have on the right-hand side? Very good. And then we have to subtract 4. And we do have to present 2 clean solutions. What is the first one? Negative 1. And what is the second one? That's it. Anything else? Yes, please.
Or number 2B?
From the same one?
Yes, that
2b, 2b, 2b. 3x to negative 4y, z to negative 7, and 3x to negative 3. Normally I should simplify inside, there is nothing I can do. Here there is a power, I have to apply it. So then I copy 3, x to negative 4, y, z to negative 7, 3 to negative 3, x to negative 3. Any questions so far?
does it matter if we do it different and set the first half over the second half?
So you wrote one over the other?
Yeah.
No, but you're working much harder.
It doesn't matter. Okay.
Let's see what you came up with, but it doesn't matter. But I think you're working much harder. So I have now 3 with 3 to negative 3. I copy the base. What happens to the exponents? But why would I say plus if it's negative 3? If you want to say plus negative 3, that's fine too. So 1 minus 3 is?
Negative 2.
X to negative 4, y. Oh, I'm sorry, z to negative 7. Now I have to do the same thing to these two. Copy the base. What happens to the exponents? That's it. So that's negative 7. So which of these 4 factors stays at the top? Only y. Everything else goes to the denominator as a form as 9, x to the 7th, z to the 7th. I wouldn't do that because I have to clean it up, and at the end, I'll do it in one step. Anything else? Anything else?
The C number, the C.
Right, we haven't really, this is just a practice. In the past, we would do more work with these, but not right now. We didn't do that a lot of this. So each and every factor has to be taken to 1/3, 125 to 1/3, x 9/1 times 1/3, power 3, 6/1 times 1/3, power 2. And you take the cube root of 125. So it's 5x cubed y squared.
So are these gonna be on the test?
Not really, because they are a prerequisite. But I did not pick a problem like these.
How many questions?
About 25. The test is about an hour long, but you have more time than that. Anything else?
Is there the extra credit?
Yes, I will consider one of those problems extra credit, yeah. Anything else? And by the way, everyone got 10 points for today for showing up.
Now, good question.
Yes.
If everybody does poorly, is there a curve?
You are not competing. This is not a competition. This is a course in which we have to move forward. Yes.
Are we just doing the test one?
Say it again.
Number 1F.
1F. So 1 divided. Natalie, you wanted something? I forgot.
Are we just doing the test on Thursday?
Yes, just the test on Thursday. So I move everything to one side and I factor x minus 4 and x plus 2. I said x not equal to 4 and x not equal to -2. Would you accept everything so far? Then you will tell me what is the least common denominator, and I draw the fraction line and I write equal symbol and 0 because otherwise I will forget. What is the least common denominator?
6 minus 4 is 4.
Very good, awesome. The adjustments,
That's x plus 2.
very good.
X minus 1.
X minus 4, and on the last one?
6.
On the last one,
6.
which means 1. Okay, so now what do I write?
X plus 2 minus 5 into x minus 1. Oh, plus.
Say it again. Very good.
Minus 6.
The reason why I refuse to write this is the same reason we talked about it twice today, and it still hasn't, it's not super clear. It's because you may be tempted to do this, and that will be a terrible mistake. That's why I refuse to write this. So now next is combine like terms. The top is -4x, and this is 22 minus 6, which is positive 16. So it's 0/1. What do I do next? Awesome. What do I get? -4x plus 16 equals. Indeed. Move 16, divide by -4, and I get x equals 4. If I had forgotten to write that, I would have lost points.